Okay, everybody. Mr. Berger did a pretty good job with the stuff he explained, but I don't think he did a good job of putting the whole idea together. In video 1, he showed us what happens when we take a right triangle and we put an altitude in it and break it into two smaller triangles, okay? And I don't think he really showed us some of the relationships that creates, so I want to talk about that. I have that down here as a diagram for you, and then I also want to have these example triangles here so we can see how they all fit together. Okay, so you can see that they're all similar when you line them up this way, okay? And I'm just going to set them like this so we can compare their sides and so forth, okay? I want to talk about, first of all, comparing short legs to long legs, and I want to use the yellow and the pink one here. If I compare the short leg of the yellow one, X, to its longer leg, H, that is proportional to the short leg of the pink one, H, and its longer leg, Y. Okay, we're going to use that in a minute. I want to compare short legs to hypotenuses. For instance, if I do that with the yellow and the blue here, if I have the short leg X over its hypotenuse A, that should be proportional to the short leg of the blue triangle over its hypotenuse, A over C. And finally, I want to do the same thing with the pink and blue triangle, looking at the longer leg, Y over its hypotenuse B. And I want to compare that to the longer leg of the blue triangle B over its hypotenuse C. And I'm going to show you why I set those up this way. It has to do with geometric mean. So this is what the part that he was missing, I think, when he explained it. Here's what the geometric mean does. It is the value. If you have two numbers, and let's call them J and K. Okay? If you have two numbers J and K, the geometric mean is the number that works in this situation. So J over the geometric mean equals the geometric mean over K. For example, let's use 8 and 2. If 8 is one of my numbers and 2 is my other number, the geometric mean is the number that goes in here. It works as the denominator of 8 and the numerator of 2. So when we solve for this, I would get G squared equals 8 times 2, which is 16. G is 4. And that makes sense. I know 8 over 4 equals 4 over 2. Well, what I want you guys to notice is that these relationships he set up down below, or we set up down below, use what's called the geometric mean. You get the same number diagonal from each other. So in this instance, if I solve this proportion, I would have h squared equals x times y. Look what that's telling you. This side squared, your altitude squared, is x times y. Or you can write h equals the square root of xy. This piece is this times the square root. Look at this relationship we have. When we have a on the diagonal here, I have a squared equals x times c, or a equals the square root of xc. So now you're talking the short leg of your big triangle is this small piece times the whole hypotenuse, square root. It also works on our last proportion, this b. So I have b squared equals yc, or b is the square root of yc. Look what that's saying. My long leg is this piece of my hypotenuse times the whole thing, square root. Okay? So we call those the geometric mean. H is the geometric mean of xy. A is the geometric mean of x, this piece, c, the entire. And finally, B, the long leg, is the geometric mean of the long piece times the entire hypotenuse. And we can use that relationship to solve for parts of triangles that are missing. For instance, on this problem, back on video 3, he did these with geometric means but didn't bother to tell you. For instance, he solved for y here, and it's going to be 3 times 11 square root. He solved for x here, it's going to be 3 times 8 square root. And then he solved for z, and he didn't use proportions, but we can do it. Watch this. So z should be, or can be solved by finding z over 8 equals, I'm sorry, z over 11, my bad. The long side over 11 equals the long side of this triangle over its hypotenuse. So z is the square root of 88. You can simplify that. So again, z is the square root of 8 times 11. Okay? You can also solve this problem with geometric means. And let's just skip straight to it. If I'm trying to find this piece here, let's just call it x for want of a better variable. This 25 squared needs to equal 5.5 times that missing piece x. And now I can solve for x. Okay, that's an easy. Square 25 divided by 5.5. Okay, so geometric means can be used to find parts of triangles very quickly, and that's what we're going to use it for on Monday. Thank you.